Hello, this is Mrs. Brown, and today we're going to be looking at dividing by a monomial. When we're doing this, the most important thing to remember is the quotient rule. If you're good with the quotient rule, this is just a few extra things having to do it, but we're going to be using the quotient rule frequently. The quotient rule, remember, is if I have two powers with the same base, I subtract the exponents, is my shortcut for that. And so if I have 7 to the third divided by 7 squared, that's 7 to the 3 minus 2, or 7 to the first. Or you can see the example down here, n to the fifth divided by n, remember that equals n to the first, is n to the 5 minus 1, or n to the fourth. If you know your quotient rule, this is going to be really helpful as we're moving through this skill. Okay, so the first thing I'm going to do, you see I've got 3x squared divided by 6x, is I'm actually going to write it as a fraction because I think it's easier to see what's going on when it's written this way. Remember, the fraction bar is a division symbol, so every fraction is a division problem waiting to happen. And when we do this, we're going to do it in two parts. I'm going to start by looking at the coefficients, the numbers that are being multiplied by a variable in front of the variable, not the exponents. When you have coefficients, you're going to treat them like normal. So for instance, if I had the fraction 3, 6, what would I do with it? Well, I'd simplify it. So I look for a number that divides evenly into both. It's 3. And so that comes out to 1/2. So the first part is to deal just with the coefficients, and that's going to come out to 1/2, which is what you would do if you had the fraction 3, 6. Okay? Now you're going to go back and you're going to take a look at your variables. Now this has an exponent of 2. This is just x. Remember, if it's just a variable, the exponent is going to be 1. So 2 minus 1 is what I'm trying to do. So x to the 2 minus 1 is just x to the 1. My answer to my quotient rule, remember, we're always going to put in the numerator. And so it's just x to the first, or x. So the answer to 3x squared divided by 6x is x divided by 2. Okay, the other thing you could do is you could write it as 1/2 times x. That's equally correct, remember, because this would be the same, because this is like x over 1. So if I multiplied those together, that would come out to x divided by 2. Okay, let's take a look at another example. I'm going to start by writing this so it kind of looks like a fraction. Okay, so in this, the first thing you're going to notice is the numerator is not a monomial. It is no longer just one single term because it has a subtraction sign in between. So this is actually a binomial. There's a term here and a term here. What this means is when I divide by 5, I have to divide this by 5 and the other term by 5. So what I'm doing is dividing every term by my monomial. So you can think of it like this instead. I can split it up so that I'm dividing this term and then I'm dividing this term. So if I do that, I just have to deal with the numbers. So the coefficient of x, 25 divided by 5 and 10 divided by 5. So 25 divided by 5 is 5, x squared, minus 10 divided by 2, or 5, 10 divided by 5 is 2 times x. So this is the answer to this division problem. Again, this is a coefficient. I'm just dividing it by a number. There's no exponent. It's like an exponent of 1. So I'm just dividing it and treating it like I normally would. I use my quotient rule when I'm dealing with powers. Okay, so something in the second or the third or so on. All right, well, let's look at what this would look like instead if I did the same problem, but this time I had 5x in the denominator. So what I'm dividing by. All right, so again, the first thing I'm going to do is I'm going to break it up by terms. Okay, this is a subtraction sign. Whatever I'm dividing by, I have to divide this one and this one by the same thing. So again, taking it in pieces, I'm going to start with my coefficients. 25 divided by 5. I'm going to do 10 divided by 5. I'm not using a quotient rule because it's just the coefficients. We're not doing powers at that point. So 25 divided by 5 is 5. And I'm going to get 10 divided by 5 is 2. And now I have to look at the variables. Okay, So remember that this is x to the first because it doesn't have 1 listed. So 2 minus 1 is 1. So that leaves me with an x. And x divided by x is 1. The x's cancel. You can think of it as 1 minus 1 is 0, and anything to the 0 power is 0. So this is the answer when I divide that out. Okay? So let's take a look at another example. This time I'm not going to write it like a fraction to start with. I want you to see the format. Okay, and I'm going to divide this by 4x. Okay, so I'm going to do the same thing. I'm going to divide. You notice that there's a plus, which means there's 2 terms. So I have to divide this by 4x and this by 4x. So I'm doing 2 division problems when I'm doing this. So I can think of it as 36x to the third divided by 4x plus 24x squared divided by 4x. And so as I'm looking at this, the same process. I'm going to start by simplifying this right here. Okay, so 36 divided by 4 is 9. And by the way, sometimes you have problems you don't have coefficients to deal with, or they might not simplify and you can just leave it. Like if I have 5 halves, I'm just going to leave it as 5 halves because it doesn't simplify. And that would be perfectly fine. And this is going to be 6. Okay. Then I go back and I look here. Remember, this is x to the first if it's not listed. This would be x to the first since it's not listed. 3 minus 1 is 2. And so 2 minus 1 is 1, so that's just x. So this is the answer to this binomial divided by this monomial. Okay? We're going to do one more example. We're going to be applying this skill to the next video, which is factoring out the GCF. So this is important to get this practice in to make sure that you understand this division, that each term is divided by it, because we're going to take it a step further in the next one. All right, so we're going to take this polynomial and we're going to divide it by 3x and see what happens. Okay. Again, if I'm looking, terms are separated by plus and minus signs. So there are 1, 2, 3. So this polynomial is actually a trinomial because it has 3 terms, which means every single one of these I have to divide by 3x. So if I'm doing x to the third, and then 3x squared divided by 3x minus 9 divided by 3x. Okay, as I'm looking at this, this is going to leave me with an x in the denominator, which is going to mess things up there a little bit. But again, I'm just using that same process of having dividing it by each term. So here, there's no coefficient. So when the coefficient is not listed, it's 1. So if I'm looking at the coefficients here, that's 1/3. Okay, because it's 1 over 3, and I don't have to do anything. I don't have to change it to a decimal. I just leave it as 1/3. All right, this is x to the first. So x to the third, third minus 1 is x squared. Okay, 3 divided by 3 is 1, so my coefficient is going to be 1. So I can just do the variable. This is an exponent of 1, so 2 minus 1 is x. Okay, if you put 1 times x, that's not incorrect. That's mathematically correct, but we usually don't write the 1 when it's a 1. Minus, okay, 9 divided by 3 is 3, and there's no x here, so this x has to stay in the denominator. And so that would be my final answer if I did that division problem. Okay, I hope this helps, and have a fabulous day.